In this video, we're going to be going over how to do the mixed type of reactions problems. I'm going to go through the first three. As I have been in the previous videos, I'm not going to be balancing these. I trust you can do that. And I also want you to try each one of these before you look up the answers, but if you are completely lost, then feel free to follow along with the first one before trying the second one and trying the third one. Okay, so the first thing that we have to do is we have to figure out what type of reaction it is. The way that we do that is we look at the reactants, right? So for our different reaction types here, single replacement, we're going to have an element plus a compound. Combination, or I'm actually just going to use synthesis. Synthesis is element plus element. Double replacement is compound plus compound. Decomposition is just a compound, a single compound, and combustion is a hydrocarbon plus oxygen, right? So based off of these patterns, we can figure out what reaction type it is. So if we look at the first one, we have sodium chloride reacting with silver nitrate. Sodium chloride is a compound. Silver nitrate is also a compound. That makes this a double replacement reaction. For double replacement, what we're going to do, so I'm just going to say DR for double replacement, we are going to switch the two positives. So the Na and the Ag will switch places. Right, so to rewrite my reactants, NaCl plus AgNO3 yield. We switch Na and Ag. We're going to get Na with NO3. Na is plus 1, NO3 is minus 1. They cancel. We're going to get Ag with Cl. Ag is plus 1, Cl is minus 1. They also cancel. We'll check our states of matter. Since this is a replacement reaction, we already have water. Sodium chloride is soluble, so this will be AQ. Silver nitrate, also AQ. Sodium nitrate, still AQ. Silver chloride, okay, silver chloride is a solid. So because we have this solid right here, all four of them are not AQ. That means that this reaction happens. So this is the equation. You just have to go through and balance it. For number 2, iron with copper 2 sulfate. Iron is an element. Copper 2 sulfate is a compound. Element plus compound means single replacement. So the iron is going to try to kick out copper. Right, so I'm going to write down my reactants. So iron, copper 2 sulfate. For single replacement, I check right away. Is iron able to kick copper out of a compound? Is it higher on the activity series? Yep, iron is higher on the activity series, so it can kick out copper. That means this reaction will happen. So we're going to have iron with sulfate plus copper off on its own. Now this gives us a little bit of a problem here because we don't know which iron to use, right? Iron can be either +2 or +3 according to your chart of charges. If I don't specify, so I didn't specify on this page which iron to use, pick whichever one of them you'd like. Okay, so if iron can be +2 or +3, pick +2 or +3, doesn't matter to me. +2 is the easier one because this is +2, that would be -2, and they cancel out, and this would work. Or if you wanted to do +3, you could do +3 and -2, drop and swap, and that would work as well. So for this question, there are 2 acceptable answers depending on which iron you want to use. So now the last thing I have to do is go in and put in my states. Iron's a solid. Copper is a solid. Copper sulfate dissolves, so that is aqueous. Iron sulfate, whether it's iron 2 or iron 3, will dissolve, so they're both aqueous. So this is our reaction for the single replacement of iron with copper sulfate. For number 3, if we take a check, we have C4H10. The compound contains hydrogen and carbon, therefore it's a hydrocarbon. We're reacting with oxygen. That makes this a combustion reaction. So just to put up here, this is single replacement. This is combustion. So combustion reaction, C4H10 plus O2 will yield. Now combustion reactions are easy because they always produce the same two products no matter what. Every combustion reaction will produce carbon dioxide and water. Right? So these are the products of every combustion reaction. We'll go through and we'll put in states. When you're burning a hydrocarbon, typically you actually only burn the vapor portion of the hydrocarbon. You don't burn the liquid or the solid. Oxygen is a gas. Carbon dioxide is also a gas. And the water, because we have a combustion reaction and it's going to be fairly hot, I'm going to assume that the water in this case is going to be a gas, although you could theoretically also put liquid here. Okay, so this is the combustion reaction. Balance this one. This one may be a little bit on the tricky side to balance because you have a 10 here, and that won't give you a nice even number to work with here, but you should be able to balance it. I think it's actually on one of the earlier parts of your balancing equations sheet. Okay, so these are mixed reactions. Figure out what type it is based on the reactants. Follow the appropriate one of the 5 patterns. If it's a decomposition, make sure you figure out which subtype of decomposition it is. Use those to make the products. For single and double replacement, tell me if the reaction will happen or not. Put in states of matter, balance it, and that's it. This is the combination of everything we've been doing for the last couple of weeks. This is what your test will probably look like. I'll give you reactions or reactants and ask you to write out the full equation. All right, so that's it. Again, if you have any questions, I will be available through email for the next couple of days. So good luck.